what did we study? What are the types of fractions we have? Unit fractions. What are unit fractions? Just the one unit. Just the one unit of anything is called as a unit fraction. So 1 out of 13, 1 out of 11. So if you just take a 1 unit out of anywhere, even a 1 whole, that's a 1 unit. So it's a unit fraction. Then after that, when we put more than 1 unit together, but still it's not as much as the denominator, we called it as a what? What was that called? 2 out of 11, 3 out of 11, even one unit fraction. What did we call it? Proper fraction, because properly we can show 3 out of 11, we can show 4 out of 11, no problem about that. Am I right? So we call it as a proper fraction. Then yeah, when we had, yeah, like let's say something like this, the numerator and denominator both are same. So as an example, this, yeah, I don't know, can you all see this thing? Yeah, if I put 4 out of 4, 4 out of 4, what is that? That makes a 1 whole round. So a 1 whole round is equal to how much? 1, a whole. So we call this as a what? A whole fraction. A whole fraction. Whenever we make a whole fraction, we replace it with a 1 whole. Does that make sense? Now then it came to the next stage. The next stage is what? When the numerator is more than the denominator. I'm sure that we went through that lesson. Yeah. When we had something like let's say what? Tell me any number, any small number. Make it a little bit bigger, like a 2-digit. 2-digit. 27. Okay. 27 out of a, maybe let's say that we got a what? 10. 27 out of 10. Okay. So let's try to make it So what's going to happen then? A 27 out of 10 means I will need how much? Out of 10 parts. Yeah, here we go. I got out of 10 parts. So let's try to make it Yeah. 1 out of 10, 2 out of 10, 3 out of 10, 4 out of 10, 5 out of 10, 6 out of 10, 7 out of 10, 8 out of 10, 9 out of 10, 10 out of 10. I just made a what? A 1 whole. So I'm going to take it and replace it with a 1 whole. Then again, 11 out of 10, 12 out of 10, 13 out of 10, 14 out of 10, 15, 16, 17, 18, 19, 20 out of 10. How much is that? And again a 1 whole. Yeah? And after that, yeah? 21 out of 10, 22 out of 10, 23 out of 10, 24 out of 10, 25 out of 10, 26 out of 10, and then 27 out of 10. There we go. We made 27. Yeah? So, how many 1 wholes did we make? 2 1 wholes and a 7 out of 10. So, the mixed number of that is what? 2, 7 out of 10. That is how this thing turned up, Is that clear? Then after that, yeah, we learned about whole numbers. Whole numbers are like, if I make another 1 more round, that's then what? A 3 whole. That means what? That means a 3 out of 1. 3 out of 1. All good, everybody? No doubts, no issues so far? After that, the hard thing started in maths. What was that? Equivalent fractions. What are equivalent fractions? Anybody knows? Fraction that is equal, or in other words, we started like simplify fractions as well. Simplification of fractions or equivalent fractions, both are kind of the same. Yeah? What's happening? Let's say that we got a 3 out of a 6. 3 out of 6. Is there any number I can divide both of them with? Out of 3. Yeah? If I divide it by out of 3, what will happen? 1 over 2. That means it is equivalent to 1 over 2. So 3 out of 6 is the exact same as 1 over 2. That is what we called as equivalent fractions. It's equal. Both sides are equal. So rather than writing as 3 out of 6, we can write it as 1 out of 2, a half. Did that make sense, Pute? Yeah, the same deal happen when it comes to addition subtraction. Why? How does it work? Let's say, Buddha, that I got a question like a half add with a third. A half add with a third. Yeah. So what did we do with it? When we had a question like half add with a third, yeah, we like in our normal grade 7 or grade 6 we studied about, yeah, let's make the denominator same. What is the best denominator I can make both of them into? 6. Using equivalent fractions, then we learned that here multiply by 3, here multiply by 3. That will become a 3 out of 6. Here multiply by 2, here multiply by 2, that will become a 2 over 6. And these two get together, that becomes a 5 over 6. Did that make sense, Pute? What is this? Visually, Pute, we had a half here, right? A half out of a 6. Look here, Pute. If I take out of 6 pieces, a half can hold up to 1 out of 6, 2 out of 6, and 3 out of 6. Can you see? That is what we wrote here, 3 out of 6. Yeah? And a 1/3 can hold up to what, Pute? 1 out of 6 and another 1 out of 6. That is how much, Pute? 2 out of 6. Here, that is what 2 out of 6 means. And then, Pute, these 3 out of 6 and these 2 out of 6 got together, and now we can call what is the addition of them? A 5 out of 6. So this is what, Pute, we did visually. Does that make sense, everybody? Same deal with subtraction. What should we do, Buddha? We have to make the denominator same and then do the subtraction to what, Buddha? Did we change the denominator here? Did the denominator change? It's still out of 6. But the numerators got together. 5 out of 6. So in subtraction, what we do is, we make the denominator same and then we take away the numerators. So as an example, let's say, Pute, that we got a 5 out of a, maybe let's make it up, 5 out of a what? 5 out of a 6, take away 3 out of a 4. Alrighty? Where will 5 out of 6 and 3 out of 4 meet each other? No. 12. 12 is the best number. Pute, 6 to become a 12, what should I do? Multiply by 2, multiply by 2. Please multiply by 3, multiply by 3. That will give me what, Pute? 10 over 12, take away 9 over 12. 10 take away 9? 1. 1 over 2. There we go. That is what we do with addition, subtraction with fractions. All good, everybody? Quickly write this thing down, Pute.